Basically, this is the zoom factor of our camera. We can control how much zoom it has got. The wider the field of view, i.e. the bigger this value, it's going to basically correspond to a zoom out in the camera. So if we say D3DX pi and get rid of the 2, it's going to be more zoomed out than D3DX pi over 2, in fact twice as more zoomed out. The next one is the window width over the window height, and this is the aspect ratio of the camera or our screen. We should make it the same as the screen, or it'll start to distort and stuff like that. Just experiment putting these numbers in. And basically this is just the ratio of the width to the height of any geometry that we're going to draw. So by declaring it as the same as the window width divided by the window height, which is the ratio to the window width by the window height, then we're going to see it as we expect to see it, with no distortions. But you can alter these and say if you make window width bigger, it will probably end up squashing the image in the Y direction. So it'll squash the triangle in the Y direction. At least I think it will. I haven't actually experimented. The next one is the near plane, which essentially is the closest things can come to our camera, or where we see it from, without them without them disappearing. It's the closest things can be. If they're any closer than this, then it won't get rendered. And this is the far plane, so anything further away than 100 units won't get rendered. So this just essentially creates a box and projects it onto our screen for us. You know, the box is going to be this wide, it's going to have this width to height ratio, it's going to start here and it's going to end here. You should read up on it, it's good stuff. The next thing we need to do is tell our graphics card about these matrices, because everything has to be sent to the graphics card to be rendered. We're going to use our PD3D device, so this is our representation of the graphics card, and the call to tell the graphics card about any transformations, be it any matrices, world view projection, is the set transform method. These are constants or definitions, or enums actually. D3D transform state view, so this is the view matrix, and we just pass it the address of the view matrix that we calculated with this call here. D3DX matrix look at LH. And the same with this, D3D transform state projection, and then we just pass it the address of the projection matrix that we just calculated here. So we've told our graphics card how we want to transform our vertices when we want them to go from space to space, in particular world to view and then view to projection. Alright. The next thing that I'm going to do in the initialize method is turn lighting off. Now you may say, why do we need to do that? And anyway, this is done by the device. We're going to set a render state. Now there's loads of render states, you've got to look in the documentation, but one of them controls the lighting. D3D render state lighting, say it's a false, and we have to turn this off because nothing will, if there's no light, it's going to be pitch black and we won't be able to see anything. But if we turn lighting off, in the sense we say that we're not going to worry about lighting at all, then we can just render the colours how we've described them in the vertex buffer. So we're providing our own colours essentially. We don't want to do any lighting or any calculations to do with lighting at all. Not yet anyway. So we turn lighting off. And that is everything that I want to do with the initialize method. Everything that I want to change and everything that I want to add. Next on to the update method that we haven't actually implemented yet. So this is all brand new stuff as well. Now in the update method, this is where I'm going to actually declare my world matrix. Because if you remember, world matrix and the world space is responsible for handling any of the rotation or translation or scaling that we want to do to our models when we take them from modeling space to world space. So this is what we're going to do. There we go, returns a handle to result, CAP update. It's passed in this change in time variable, and then what we're going to do is increment our angle by 1 degree, working in degrees, times the amount of time since this angle was last incremented. So this is a way to make sure that we increment our angle the same depending on what speed the computer is, because say we have one computer and it took 0.1 seconds in between updates, there was 0.1 seconds. So that means that we're going to increment the angle 1 times 0.1. If there was 0.2 seconds, we're going to increment the angle 1 times 0.2, but 0.2 seconds has passed, so although it'll be more jerky when 0.2 seconds has passed and we increment this angle, although it'll be more jerky, it will still increment the angle by the same amount as if 2 0.1 second calls had been made, if that makes any sense. And this is kind of the one of the reasons for when you get glitches and stuff like that in computer games and you get lag, because say there's a big amount of time, like 10 seconds, there's this update method hasn't been called in 10 seconds, then it's gonna increment by 10 degrees at once. So it's gonna it's gonna lag and it's gonna move all of a sudden all at once, because this is gonna be incremented by 10 degrees. Yet if we like a nice smooth frame rate, and this is 0.1, which signifies it's last call 0.1 seconds ago, it'll only increment by a very small amount, so it'll be nice and smooth when we spread it over an entire second or something like that. Now the next thing is we're going to create a rotation matrix, which will be our world matrix, and we're going to call it D3DX matrix rotation Y. And what this is it creates a matrix that will allow our shape to be rotated around the Y axis. There's equivalent ones for X axis and Z axis, but if we rotate it around the Y axis, how do you think it's going to look? If the Y axis goes in this direction on the screen, it's kind of going to rotate like a merry-go-round or something like that. That kind of rotation. If it was Z axis, which goes into the screen, it will rotate like a propeller. And it will also rotate about the origin of the shape as declared in modeling space, which is why it is a good idea to declare the center of your object in modeling space to be 0.000, because that means that it will rotate about the center of the object.